Hello everyone. Today we're going to talk about SpEL Injection in a Spring Boot application and how it exploiting it and on our vulnerable application PinewoodStore would allow remote code execution. The first thing is let's go over what an injection is. Just a common general definition, right? So an injection vulnerability occurs anytime an application accepts untrusted or unsanitized data, and the interpreter or the engine of the application processes that data, resulting in unintended commands that could allow remote code execution or any kind of exploitations. Now, some examples of injection is just SQL injection is a commonly known injection vulnerability, like it has been used to exploit vulnerabilities in multiple big companies. So, and the other one is command injection. That is not as common as it used to be because as developers are learning a whole lot about injection vulnerability, they don't actually allow any kind of commands to execute at application level. So you don't see that more often than like the SQL injection. And the other one is not widely talked about, a SpEL injection. Now, what is SpEL? SpEL is just a Spring expression language. It's a dynamic expression language used across Spring framework, used for querying and manipulating objects at runtime. Example would be accessing bean properties. You could use kind of like user.name and put it inside parentheses. You'd be able to do it would evaluate that for you. Another one, just like inside parentheses, 1 plus 2, or maybe 5 times 10, or any kind of expression. Now, with this comes the probability of using this to exploit a vulnerability, right? And the other one is just a math, kind of like you can carry out, like you can use the java.lang.math library and maybe find the square root of 16. Now, what can an attacker can do? An attacker, if a user supplied input is not validated, or there's no sanitization, an attacker can supply data that actually allows some kind of code execution. Now we're going to see this, remote code execution in our PinewoodStore. I introduced the vulnerability already. So this is kind of like the source code that I used on the backend is actually running already, and it accepts user input and just processes SpEL expression, and that's the reason why it allows the remote code execution. Now this is just basically an example. Like if you find a vulnerability like this is actually my blog post, but if you find a vulnerability like this, some of the things that you can do to kind of validate this is a vulnerability, right? For an attacker, getting in what operating system the application is running on might not be kind of like useful unless you're doing some kind of bug bounty program just to see that there's actually SpEL expression injection vulnerability. You want to show that, then yeah, you can use something like harmless commands like os.name, and it will show the operating system, and you can just use that to get a proof of concept. And also find current user, you can also use this. And the easiest way would be just putting in parentheses inside parentheses some mathematical expression like 5 plus 6, or like 8 divided by 2, or something like that. So if it evaluates this, it means it's just it is actually vulnerable to SpEL injection. So let's go ahead and take a look at our application. Now the vulnerability has been introduced on this page, the security page. So if I were to refresh it and go back to VERP, and you see there's actually a request, a GET request that is going, and it's using an expression word. So the first thing to test is this some kind of library or a function? So I'm just go ahead and send it to a repeater. Let me send it again just in case. So this is URL encoded. You can select it, you can see what it is. So sending this and getting that. So let's try to see if we can change this to a simple expression that does addition. So apply the change and send it. So it is doing the expression. So this is actually vulnerable to SpEL injection. So the next thing is, and obviously an attacker most of the time would need to execute some kind of remote code execution. In our case, we were trying to demonstrate remote code execution. So what I'm going to do, I'm going to use a well-known library, java.lang.runtime, and execute and run a command and open up the calculator on my machine, so, or the machine where the application is running. If it is a Linux, obviously you're going to use something like genome calculator, and since it's actually I'm running it on the Windows, I'm going to use just calc. So T and runtime exec. Yeah, this is a basic building block, and then we're going to populate what's inside. So this will be java.lang.runtime. And the command it would execute obviously is going to be open up the calculator, so it'll be calc. I believe we got it right, so apply, and let's go ahead and send it. I don't have a calculator open, as you can see. Alright, so it opened it up here, as you can see, came up, and also just to prove to you that it actually produced process ID. So that means there's actually there is a process that gets created when it executes a command. So alright, so that basically it, just to demonstrate how a SpEL injection can happen and get exploited and give the attacker a remote code execution. Obviously the first thing to do is just to watch out how to prevent it. Never pass input validation, input sanitization everywhere. If we look at the vulnerabilities that I introduced, it's just a Spring controller in the back end. It just has the endpoint info security and accepts a string expression, and it just passes it to the parser, the expression parser, and that's why it is actually, if you apply some kind of input validation, even if you're using this at the front end, you might be able to get protected, some level of protection, and avoid this kind of vulnerability from being exploited. So that's basically the vulnerability that I introduced. And the first thing is to remediate against or to prevent this kind of vulnerability. Validate input, validate and sanitize input, protect such endpoints. Also, if you notice, this endpoint is actually, it doesn't require me to authenticate. So if you need to use kind of like a library like SpEL Expression or something like that, it would be best to minimize the exploitation possibility. It needs to be behind some kind of authentication. I could have put it inside where it required authentication, but I wanted to make it simpler to this lab, because this lab is just to demonstrate how it could allow remote code execution. Even allowing it after authentication could be bad, because sometimes, unfortunately, customers could be the bad actors too if they find a vulnerability like that. So, and avoid using SpEL altogether.